I'm recording. I'm unsubbing. Okay, so last class, you had a lab, and the lab was to have a parent spawn a child every 1 second, right? And then when the parent received the interrupt command from the terminal, the parent would then kill off all the children? Okay, gotcha. So what has to happen? So this was kind of putting together several of the things, several of the things we've talked about this last week. So we've talked about raise versus kill. We've also talked about the fork command. So we want to understand a couple of different things here. When a function, what we call the fork command, the child process gets a copy of all of those things, but the child process also picks up from where the parent left off. They don't get to go back and restart main, which was based on some of the questions that it seemed like I was getting. So let's kind of take this step by step. We'll build this solution. Let me start off of one of our signal things. I'll just steal this and we'll gut some stuff. All right, so let's call this killkids.c. That'd be a nice, a nice file name. All right, let me paste this in here and gut some stuff. I'll get rid of these things. I'll just keep the handlers in here for right now, and then we'll say received SIGINT. All right, so initially we want to create a scenario where the parent receives SIGINT, which we've done that. We've had some examples, but let's just get this code to that place. So inside main, we're going to go ahead and register. So we'll say signal, and we're going to say we're going to respond to SIGINT, and our handler for that is sig handler parent, like that. All right. Now, how do we tell a running process to wait for a signal? What's our function that tells a running process to wait for a signal? Pause. Okay, so we'll just tell the parent to pause. So that's all this guy does, right? This application launches, registers itself for SIGINT, and waits. Make sense? All right, let's see that that's the case. GCC kill kids.c. All right, so this guy's waiting, right? And then I'll give it the interrupt, parent receives SIGINT. All right, so far so good? All right, so now we're able to tell our parent when it's time to kill your kids. This is great for soundboard. I was disappointed that you guys wanted to go last and you didn't even do the Pokeball catching me. Was there something special about whether your Pokeball catching me would not work?
Josh changed it. Like we just didn't have enough time to make it universal for every professor, but it's like fixed now.
Okay. And does something special happen when you try to capture me?
We're gonna implement that where it plays theme music and like you actively chase the player.
Yeah, that makes sense. Yeah. Plus, there wasn't Mr. Gonzalez on there either.
That's a legendary.
Yeah. I told you last week he has rabies, right?
Yeah.
It's not getting any better either. My wife woke me up at 4 a.m. last night because we had coyotes um, running through the neighborhood, I guess, because they're doing their screaming stuff. And so she wakes me up because she's all scared. And I mean, we live in the suburbs. This isn't like, around the country and coyotes are a regular thing. And so while she was freaking out, I'm funny even when I just wake up. So I grab Mr. Gonzalez sleeps in bed with us. So I grab him and I hide him. And so she's like, you hear the coyotes? Like, well, where's Mr. Gonzalez? She's looking around. She's like, I don't know. Where'd he go? He's chasing him. He's rabid. No wonder they're screaming. And she thought it was true. Got him. Mr. Gonzalez is unhinged. It's not good. Can you imagine living in a house with him? And then there was like, I need to put a TikTok thing up with him one of these days. But yesterday at church, my wife, she wants to get her hair cut. So, so she took her hair and put it over Mr. Gonzalez, like dressed him up. You see it? I'll try to post it online right here. We'll get it in the channel. CSC450. All right, so it's going to go in the 450 Slack channel. That was my wife at church yesterday, putting her hair on Mr. Gonzalez. It reminded me of this, it's a comedy guy, Michael Che from Saturday Night Live, and I've seen it on TikTok where he's talking about women. He walks through a neighborhood and you see a pit bull roaming wild in a neighborhood, and you don't go in that neighborhood anymore. That's a dangerous neighborhood. Where a woman, she'll catch the pit bull, she'll train it, she gives it vegan treats. This dog used to win tournaments. Now his name is Nicole. There's a whole bunch of TikTok videos that show that with these ladies with these giant pit bulls, and they're feeding them like little snacks. I don't know. That's how I spend most of my free time. What are you gonna do? All right, so our parent knows how to receive a signet now. So now we want to teach our parent how to spawn children, right? Okay, well, that one's easy enough. So we're going to throw a while loop in here, and we're just going to do it forever for right now. Now we do want to do something here. So we're going to write a little comment up in our handler here. So we're going to say kill kids. And then we want our parents program to exit, right? We want to kill it off. That way we get out of this while loop. What's going on here? Okay. So inside the while loop, what are we going to do? Well, we're going to call our fork system call, which creates a duplicate of this. And we're going to capture the process ID of that guy. Previous times, I think we've written it as a PID type, right? PID-T. That is an int. If I type in PID_T, it's a type def for an int. So you can just say int PID. Pick your poison. All right, so we'll call the fork system call. We'll get our process ID. We'll say if PID is equal to 0, that means I'm the child, right? So if I'm the child, what do? Well, the child waits. So they first have to register themselves with a signal. We're going to choose a signal that they're going to sit there and receive from the parent, right? So we're going to we can do almost any signal we want, but why don't we use one of the built-in user signals like sig user1, something like that. So we'll go ahead and say signal sig user 1. And our signal handler will be, what did I call it? Sig handler child, that dude. All right, so sig user 1, we'll call sig handler child, and then the child waits. Now what we can do is here we can give a little commentary. So we can do like a printf. Child waiting, well, child born, child waiting. And like you told me before, the way we wait is with a pause, right? So now we're just waiting for some signal, presumably coming from our parent. Okay. Now, if we're the parent, what do? Well, we're going to, for right now, let's sleep for 1 second. Okay, we'll sleep for a second, and then we'll spin back up and we'll create another child. All right, so that's this current thing. Now, what do we want to have happen? So as our current code goes, it says the parent's going to register themselves with SIGINT. Now, an important thing here is when we use the signal function here to register something, we register this PID with this signal for this handler. What does that mean? That even though in here, if we're the child, if we're a copy of this original parent, we are not actually registered with that handler, because the handler, this registration happens at the process ID level. The original parent, which has a process ID, they are the one that is registering with the operating system signal subsystem for signal handling. So when we get down into the child here, even though the child becomes a copy of this program, gets a copy of all the memory from this program, they have not been registered with the system's the operating system signal subsystem, because only the parent's process ID registered themselves. If the child wanted to register themselves with that one, they could come in here and say, okay, I'm going to register now my process ID with the signal subsystem. But in our case here, the child's not interested in SIGINT, right? We're going to let the parent communicate with the child through sig user 1. All right, so if we are the parent, we're going to say we receive SIGINT. Our job is to kill the kids. We're going to have to ask the question, how do we do that? Here in a second. And so a way that we may have previously decided to kill off the kids would have been to raise a signal, right? What's the difference between using the kill command to send a signal and raise to send a signal? What does raise do? Does whatever raise calls a signal handler themselves. Now here's an interesting caveat that I don't know if you maybe ran into or not. I'm gonna actually delete a little bit of this code for a second, just to show you something. Let's say that the parent says, I'm going to raise, let's just do like a sig kill. And we don't even need the parent to register anything. Okay, so this is kind of an interesting caveat of the raise function. So we're gonna say the parent, his one job in the world is to scream sig kill. All right. Well, what's interesting is I have not registered a handler for sig kill. What do you think this what do you think this program is going to do? And actually, let me not confuse the issue here. I'm going to call this sig user 2. The answer is going to be the same, but I don't want you to go down a path of, well, what's the default behavior for sig kill? What do you think this program is going to do right now? What does this line do? What does raise do? You told me raise sends a signal to yourself, correct? All right, so when the parent gets to line 22 here, they're going to send sig user 2, that signal, to themselves. Now, we've written a couple of handlers here, but we have not registered a handler, have we? I'm not doing any child parent stuff at all. All I'm saying is this program is a simple signal handler. I deleted the stuff I just had a minute ago. So this whole program's job right now is to come in and raise a signal. But it's a signal that he has not registered a handler for. So the question is what happens? What's the behavior of raise when we have not specifically written a handler for it? And we're going to see that raise blocks. Raise expects that if you're going to send a signal to yourself, that you have written a handler to handle that signal. In this case, we have not, or at the very least, we didn't associate that handler with the signal. So if I go and run this right now, oh, it does have a default handler for it. Let me do sig int. Will that do it? Yeah. Well, actually, no. I want raise to block. I'm going to not return there. Raise does block if I don't do anything else. And we're not doing that. We're going to raise that signal to yourself, but we didn't register anything. I think I do need to do it as a pause to keep it from ending, because what's happening is we're saying we're going to raise a signal, let the program run to completion, but we don't have a handler. We can't pause before we raise. This should at least block. Not blocking either. Am I saving this? Let's make sure that does what I'm expecting it to do. All right, that did raise the signal. So now we'll say we don't have a handler for this. All right, so nothing came out, that's fine. But then we said pause. Does pause not have a behavior if we haven't registered with any signals? Doesn't look like it does. So let's go ahead and register with sig user 2, but we'll raise sig int. Now we'll pause. We're registering this, we're raising that, and then we're saying we're going to wait. We're never getting into this handler, which is correct. Suspend the process until the signal arrives. Why isn't this pausing? Just for the sake of argument, let me throw this inside of a loop.
Result with the raise call. It's like in the manual page, it says that raise returns 0 on success and non-zero for failure.
But even then, pause should still be stopping us. And this program is immediately ending. We're not getting anything. What'd we do? Am I even in the right file? Force it to sleep. What's going on? All right. Printf, hello world. Something is funky. Okay, there's our hello world. Got it. So now we're going to say for ever, so while true, raise something, sleep for 2 seconds, raise it again. And then we'll say print spend too much time on this if something funky is going on. It's just dying. Maybe it's some kind of protection mechanism inside of the while loop that the compiler is trying to be smart. Okay, so that slept for 2 seconds. That worked. Then if I do raise SIGINT, okay, it was 2 seconds. Then it raised SIGINT.
You can register to sig_DFL as a default signal handler.
Well, that should be the default. I mean,
Like on examples online, I've seen them do that before they release.
Wait, did you have it registered to the SIG handler parent? Because then you have the exit.
I don't have it registered to any of them.
But before.
Before, yes. So you're thinking it's still registered in the operating system, but that would be a different process ID, so it shouldn't make a difference. Right here, I'll take the exit off of there. It's coming in, it's sleeping. Then we're raising SIGINT. We know this works if I change this to SIGINT here. So we received a signal, hello world. So is the behavior, I thought raise blocked, but it seems like raise, if you don't have a handler for raise, is actually crashes or just exits out. Because if I don't have a signal handler here, and I sleep for 2 seconds and I raise SIGINT, which I have not handled, I never get to this line. This program immediately ends. So saved. But that wasn't the behavior I expected. I expected it to block. So we're waiting 2 seconds. I raise the thing that I have not handled. Great. So I thought it was going to block here and wait. Instead, it just died on this line because we never got to this line. And the process ID for this has ended, I believe. PS-AX rep for a.out. Yeah, it's not running anymore. So the process did die, but instead of raise blocking, raise just caused the program to end. That's fine. We're gonna register anyway, so it's insignificant for what we're trying to do. I just thought the behavior of raise was different than that. So it looks like raise crashes unless you play ball. Playing ball means that don't raise a signal that you haven't specifically said you're gonna handle, is the punchline. So if we go back here, let me put the stuff, oh, looks like I had deleted some stuff. So we're gonna go ahead and say while true, first we're gonna have our parent register themselves, signal SIGINT with SIG handler parent. So when we SIG interrupt, that's when we're gonna come up here and we're gonna kill the kids. And we'll do our exit 0 here, that way they all die off. Well, that way the calling parent dies off rather than it being stuck in this infinite loop. We'll go ahead and sleep for 1 second. Then we'll go ahead and say int PID is equal to fork. If PID is equal to 0, we're the child. What do children do? Children listen for sig user 2. So we'll say the parent's going to send signal user 2. So we'll say signal sig user, well, sig user 2 is fine. And this will be sig handler child is what we'll call. So if I'm the child and I get sig user 2, I'm going to call my sig handler. What's the parent's or child sig handler going to do? We'll have them receive, we'll say child received sig user 2. now dying. And we'll tell the child to exit, killing the child process off. All right. If we are the, and then we tell the child to pause. So the child registers themselves for a signal, and then they wait for some signal to arrive. That's what the child's going to do here. We're not dealing with threads yet. We'll add threads in next. But child says, I'm going to register myself. I'm interested in SIG user 2, and I'm going to go ahead and wait for some signal to arrive. Else, I'm the parent. And as the parent, what do I do? And actually, I'm going to do this. I'm going to move my sleep down here. If I'm the parent, I go ahead and I sleep for 1 second. And then I'll spin back up and create another child, so on and so forth. All right. Now, here inside of parent, we need, we currently have PID is equal to the process ID of the child that was just created, right? All right. So in order for the parent to send a signal, and specifically in this case, SIG user 2, in order for them to send it to a child, they need to use the kill function. And the kill function requires the process ID of the process that you're trying to send the message to, sending the signal to. So that means I need to have a collection of signals. And I'm going to need access to that collection here inside of SIG handler parent. I'm also going to need access to that collection inside of main so I can add process IDs to that collection here in the else. So up here, I'm going to go ahead and I'm going to create a int child PIDs. And I don't know, let's allow ourselves to have 1,000 of those max, just because. And then we're going to have int num children. That guy will start off at 0. All right, so we're going to keep track of how many child PIDs we have and the number of children. Before we sleep for a second, we want to go ahead and say child PIDs at bucket num children is equal to PID. We're going to add the current process ID to that bucket. Then we're going to go ahead and say num children is equal to num children plus 1. Increment our number of children. And then we'll sleep for a second, spin back around, create another child. If we're the child, we register and wait. If we're the parent, we add the process ID of the child we just created to our array, increment our number of children. The parent eventually gets interrupted when we do a control C. So now our job is to kill off the kids. And to kill off the kids, we need to send SIG user 2 to each of our children using the kill command given their process ID. All right, so we'll go ahead and say for int I is equal to 0, I is less than num children, I plus plus. And then we're going to send the kill command. Kill command takes the destination, the process ID, which is child PIDs at bucket I. That's going to be our process. That's going to be the process ID of the child we're sending this message to. And then we're going to send SIG user 2 is the message we're going to send. So the parent's going to go through all of the PIDs of their children, sending to this process ID this signal. Each child was expecting to receive that signal and was specifically waiting for a signal to arrive. The child is going to receive that signal, say, receive SIG user 2, now dying, and then their program exits. And we can even do PID %D. So this will have the parent or the child get their own process ID showing that these are different children dying off. So a child will say, I received a SIG user 2. Now I'm dying. My process ID is this number. And we'll see that multiple children are going to kick the bucket here, showing that multiple children received this signal from the parent, but they received the signal in a targeted way. That is, the parent sent the kill command to this specific process ID. Well, they sent this signal here, user 2 signal, to this process ID, and they're going to do that for each of the process IDs they've collected. All right. SIG handler for the child just says, hey, this is what's going down. Now I'm dying, and they end. Parent goes and does this for each of their children and then ends. And the parent only does this when they receive a SIG int. All right. And whenever a parent has created a child, they add that child's process ID to their list of child PIDs and then increment the number of children, and then they sleep for a second. So we'll go ahead and run this guy. So every 1 second, we should see a new person created. Are we not giving output when the child is created? Oh, we're not giving any output. So children are being created. So now we'll go ahead and send our interrupt signal to the parent. And there is the parent killing off the various children. And that should do it. So all the children should be dead now. PS-AX, grep for A.out. The original process is now dead. So I think that should solve for Friday's lab. Does that look correct?
Yes.
Okay. So questions about that before we turn our attention back to communication going the other way. When we were having our children all talk to our parent. Well, actually, no. The original thing was the parent keeps spawning off children. The children then have this secret master plan to kill off the parent, right? But the children need to keep track of the number of child processes that have been created. So they need to know a couple of pieces of information. They need to know the parents' hit points, right? And I think, didn't we write some of that at least? Let me go back in here. Here's our one shot. I'm going to clean some of this up. Just call this good enough. Do I already have the, what is it? I have to seed the random number generator and then call it. So random num gen C. So here, this will initialize it. And we need to give ourselves our variable of time. Ay, ay, ay. So this seeds our random number generator with the current system time in milliseconds. Then we'll go ahead and get a random number. So we'll do, let's see, who needs to have access to the parents' hit points? Probably all the children need to know about the parents' hit points. So we'll make this a global. So int parent HP. We'll start that off at 0. Inside here, we'll say parent HP is equal to rand, I don't know, mod 20 plus 5 or something like that. So that'll give us a random number between, actually, we probably want to have fewer children than that. Let's do 10. So this will give us a random number between 5 and 15 for hit points. So it'll take 5 to 15 kids to kill off the parent. Okay, actually this is 0 to 9. So this will be 5 to 14. 9 plus 5 is 14. All right, so that'll be the parents' hit points. Now we want to prove that our children have access to that. So when we're doing that lab, we want to think about what variables do our children have access to? And one of them they should have access to is our parent HP, because this is a global variable here. It's a plain Jane int. And when you call the fork system call, all the children get copies of that memory, right? So what we can do here is we can go ahead and say, well, this is fine. We're going to say print f. Actually, we don't even need to do it at the signal handler level, but let's do it at the signal handler level since that's kind of where we'll be. We'll say mommy has %d hit points. Parent HP. And then the kid will kill himself. Very, very morbid. All right. And it's just how it works. All right. So then we'll go in here, we'll do something. So while true, effectively, we'll say int PID is equal to fork. If PID is equal to 0, we'll register the child for, I don't know, SIG user 2 again. And this will be SIG handler child. And then we'll tell the child to wait. If I'm the parent, then what do? Well, I'm going to go ahead and I want to probably, just so we have time for the child to finish registering themselves with the signal subsystem, we're going to tell the parent to go ahead and sleep for a second. And then we'll have the parent send the SIG user 2 to the child. Actually, it's the other way around, right? So parent will sleep for a second, then they'll send to this process ID, this command, or this signal. The child has registered themselves with that signal. And what do is they advertise that, yes, indeed, I know how many hit points mom has. Proof that that variable got copied over and is accessible through our handlers. Make sense? Okay. And then the parent will go back and start doing their things again. We can kill off the parent ourselves using a SIG int, not from the child, just the normal SIG int that we haven't registered. So that'll allow us to bail out here. So we'll go ahead and save that. Come out here, and what did I call this? This is one shot, GCC one shot, time H. We didn't include. All right, mommy has 9 hit points. So each kid every 1 second, proving that they know how many hit points mom has. we'll go ahead and kill off the parent. So now the parent has died. All the children killed themselves as soon as they advertised. They knew how many hit points. It's a very low birth rate in this population. Well, the birth rate, I guess, is high, but the survival rate is low, extremely low. All right, so we'll come back next time. We're going to finish writing this, where we have that communication that happens between the children, and then also communication back to the parent. Questions, comments, concerns, bribes. Make sure if you went to the hackathon, you upload the picture of you at the hackathon. Otherwise, remember the assignment is due by midnight on Friday. And you upload the picture or whatever evidence you have that you were at the hackathon to the same assignment box as the people who are doing the other homework. All right, I'll see everybody on Wednesday.